Today's adventure begins with this. This is the timer control board out of a Breville 450 XL coffee grinder. Most of the bits of which are sitting right here. And this allows us to set a time with the knob here, and when the button is pushed, it will run the grinder for that set amount of time. I noticed for a while with the unit closed up that the area around this timer got real hot, and after seeing this circuit, I understand why. Well, as you might imagine, it's apart because it broke. After a little bit of testing, the original relay was bad, and so I got on eBay, ordered a replacement relay. This is the new one. Unfortunately, that didn't solve it. The passives on here seem fine. The diodes were checking out. So that leaves me either with this triac here that is switching, but I think more likely something happened and blew the little microcontroller here for this circuit. So I did find a replacement board. This is out of production. There was a website that had it for 16 bucks, but the shipping was as much as the part. And so that's $30. And to buy a new espresso grinder that would be an upgrade to this, we're talking $100 or $200 or $300. So, taking a look at this circuit, where it says L here by my thumb, it's fused, or it was fused. And then neutral, that was the 120 volt AC input. And basically, that 120 volts was controlled by this relay here to send power to this motor here to turn it on. Most everything else is designed for this timer circuit, so I'm not an expert on electronics, but taking a look at everything, it looks like they were using these big resistors to dissipate a lot of energy and create a little voltage divider, along with some of these Zener diodes here. And so it looks like they were doing something like a half wave rectification and a voltage divider to get 12 volts DC, and then using that 12 volts to power the microcontroller. And the microcontroller was taking a resistance reading from this potentiometer here and energizing the coil on the relay with 12 volts in order to power the thing for a certain amount of time. That's great. So I decided I don't really need a timer, I just need an on-off switch. And so I just need an easy way to turn 120 volts AC into 12 volts DC to power the relay to switch on the motor. And so what I've done, let's get that out of the way. What I've done here, and only partially hidden. Whoa, easy there, fella. With Amazon Prime, this buck converter transformer set that will take this down. It's a 120 volt to 12 volt DC converter. With the one-day shipping, I had to pay $2.99 extra for that. It cost me $12. And so basically I ran the 120 volt line to here and used a breadboard here to join up some of the wiring and then wire up another one of those relays that is identical to this. I got 10 of these for something like $6. Right, difficult to see back there, but the relay is all wired up. And I did some testing. This relay takes 33 milliamps to hold solid. and turn on. And so I'm just using some fine wire here to connect it to a switch. And I'm at the point now where I've got proof of concept. This will power on. I just have a few more things to add to this. So let me, that's leftovers from lunch. I need to put this away. Let me plug this in real quick. I think that'll be off. And we'll see if I'm correct or not based on when I plug this in. Okay. So you heard that. So, all right, proof of concept again. Grinder is on. And since I have a hard time doing two things at once, apparently, I wasn't able to frame that. So this grinder also has a couple of safeties involved. So in the original circuit, these two micro switches, one here that indicates whether or not the bean hopper is actually installed, and this one here, which attaches at this point right here, will indicate when the coffee grounds container is inserted. And both of those have to be depressed to complete the circuit. And they're not intended for high current, but again, that relay takes 33 milliamps of power to energize, so I'm not really concerned about burning up the micro switches. Topaz. This is the kitten of menace. Come here. Hey, you're fine. I'm gonna put her up on my shoulders and get her out of the way. And she decided she doesn't want to stay there. That's fine. Still working on teaching her that the computer desk is not someplace she is welcome without using a spray bottle. Topaz. Yeah, she knows her name. She's just being coy for the camera. She is a remarkably sweet kitten, but she's also a pain in the rear. So anyway, at this point, what I have remaining to do is to disconnect the load lug of this switch here, pass that through these two micro switches around, and then reconnect on the other end so that these two micro switches will also prevent power. And I thought I got all the pieces put together in a little bin when I was taking it apart, but I have lost a little insert here that pushes up on the micro switch. And so I'm going to have to 3D print another one. I swept the floor, looked on top of the shelf everywhere it might have been, and I can't find it. So thankfully, this is exactly just the sort of perfect little doodad that 3D printing is so useful for. And then I am concerned with how to attach this switch into the coffee maker proper. So if we compare sizes here, right? A little bit of a hot dog in a hallway situation here. So what I'm going to do is 3D print a little piece that will snap in this hole and provide a little ring for this snap-in lighted switch to clip into. And additionally, just a little plug here to cover that hole. And then I'm also going to wire the 12-volt ground reference directly here so that the little light on this switch will operate. Right now, it's obviously not connected. So just a few more things to do. And So with that, I'll end this video and bring it to part 2.